So let's begin our discussion with arrays. When you need to store n number of elements of same type, you use array. For example, this is array declaration. This basically means a space will be reserved in the memory for storing 5 integers, right? So let's say if this starting address is 1000, then this will be 1004, this will be 1008, this will be 1012, 1016. So space will be reserved. As this is local variable, it will be stack. So you remember this? Code segment, right? Data segment. And data segment has stack, heap, and data section. So we discussed this in earlier video about the structure of program while it is in execution. When you declare an array like this, it will reserve the space for storing 5 integers from stack. It's always a contiguous memory space. That is, array elements are stored in sequential manner. You can also initialize the array like this, right? So while you declare it, you can say 27, right? In this case, the values will be 11, 22, 23, 25, and 27, right? When you initialize the array at the time of declaration, you can skip this limit specifying the size of the array here, right? But let's say you do specify the size and you do not initialize it totally. Let's say you only initialize it till here. In that case, the rest of the elements will be initialized as 0, right? And in case you do not initialize at all, right? In that case, it is mandatory to provide the size of the array at the time of declaration, and all of these will be some garbage values. Cool? One great thing about array is that you can get the base address of the array. That is the starting address, the address of the first element of the array by the name of the array. So when I say A, I get 1000, the starting address. So if you decide to print it, you could say addresses are always positive integers. Usually they are in hexadecimal, but when you convert them, they are in positive integers. So %u, that is unsigned int, and if you say A, this will print the value as 1000 because this is the starting address of the array, right? Now, so if I want to access the first value, I want to print the first value, I can say %d star A. Remember this operator? Value at address operator. So A gives you starting address, that is 1000, right? So value at 1000 is 11. So this will print 11, right? Let's suppose you want to pass this array to a function, right? Let's say we have written a function to display array, right? B of I, right? This is how I print my array content. So I have written a function for it because I want to print it multiple times. So I'll just call this function. Now, when you call this function, right? How do you make this call? So let's say this is our void main. Now I want to display this array. So I'll call that function. So I'll say display, pass the array name, right? So I'll say A and size, that is 5. So this is my call, right? So this is a call to the function, and here we are using pass by value technique. Pass by value means making a copy of the actual parameter, right? So this array will be copied into this array. So on stack, we already had this array, right? Array A. Now, for this function, we will create another entry, that is B, on stack again, right? And it will be similar, one more array, 55, at some new address, let's say 2000 to 2016, right? So you see the problem here. We are copying the entire array just to use it in another function. We are not just copying one value, we are copying the entire array. Now there are only 5 elements in this array. But imagine, what if we have an array of 75 elements and we need to display it? Every time we call this function, we'll copy 75 values, we'll create 75 values, 75 integers on stack. How much memory it will take, right? And then I'm just taking a number, 75. It could be even more than that. So it's not a good idea to pass the array by value to a function. Let's look at something called as pointer arithmetic and how can we use pointers with arrays. Now you know that array name gives me the base address, that is 1000, right? So if it gives me address, can I store it in a pointer? Yes, of course. So I will say integer star p equal to a. Now p here is a special variable because it has a star. That means it is going to store some address. Address of whom? Some integer, right? And a is the address 1000. It's the address of some integer. So we can assign a to p. Why are we not using ampersand here? Because as I told you, array name itself gives us the base address. So we don't need to use ampersand, which we usually do something like this, right? Integer x equal to 5 and let's say integer star p equal to address of x, right? You know this, right? But we are not applying ampersand operator because name of the array itself is a base address. So once we do this, now it means that p is also storing 1000, this address, right? So you can imagine p like this. P is a variable which is storing the value 1000, which is address of 11, and itself it will have some address, let's say 2000. Star p, value at address stored by p. Address stored by p is 1000, value at 1000, 11. This will give us 11, right? What if I say a plus 1? What will I get? A is 1000, base address. What if I say a plus 1, right? So a plus 1 will give me address of next element in the array, that is 1004. Now I can also assign this to p, right? P equal to a plus 1. So now p will store address 1004, right? And if I say star p, will get 1004 value 22. So I can now, once I have the base address, if I increment it, right, I can access the rest of the elements of the array. Let's say int star p equal to a. So p is storing 1000. What if we say p equal to p plus 1? What do you think will happen? P initialized with address 1000. That is the base address of the array. And then if I say p equal to p plus 1, will p become 1001? The value of p? No, it won't. Instead, it will become 1004. Why? When you increment pointer, the type of pointer is integer pointer. It is supposed to store address of some integer. It was at the beginning storing the address of some integer. That is this integer, right? When you increment that pointer, it will try to store address of next possible integer. And next possible integer is at 1004. So when you increment p equal to p plus 1, p will become 1004. It will store the address of next possible integer. And next possible integer is at location 1004 because integer occupies 4 bytes. It's a 32-bit or 64-bit compiler. Now this is a great discovery. So I'll give you certain notations now. Now p equal to p plus 1. So p is now storing address 1004 and star p will be value at 1004 is 22. So star p will be 22, right? Now, so I'll take a counter, integer I equal to 0, I equal to 0, I less than 5, I plus plus, right? And if I want to print the value, I'll say printf. I'll print the addresses %u, right? P plus I. And then I'll print the values. I'll say printf %d star of p plus I. I0, so p. P is a, right? So that is base address. So this will print first address, that is 1000, right? Then star of p plus I is 0. So star of p, address stored by p currently is 1000. Star of p, value at 1011. Right? Subsequently, when we counter increments, p plus 1, as I told you, when you try to increment integer pointer by 1, it will try to point to next possible integer. So p plus 1 will be this address. So it will print 1004. And when you apply value at p plus 1, that is value at 1004, will get 22. And when we run the loop, it will be basically 1008, 1012, 1016, and this will be right. So we could basically print this entire array used by assigning base address to pointer and then just incrementing the pointer in the loop and then applying star to get the value. All these following notations are exactly similar. So we can say p, we can say a, we can say ampersand a of 0, or we could say p plus 0. All of this will print the address that is 1000, right? So all of these are exactly similar. What if we want to print the value? Star p, you could say star a plus 0, or a, you could say a of 0, you could say star p plus 0, or you could also say simply p of 0. All this will print the value 11. Let's talk about address 1004, second element of the array. So we'll say p plus 1, you can say a plus 1, you can say ampersand of a of 1. So all of this will give you the address 1004. And how to get the value of second element? You can say star value at p plus 1, you can say star value at a plus 1, a of 1, or you could also say p of 1. Right? They will all print the value 22. Right? So all these notations are exactly similar. And although you can get the base address of the array using a, so a equal to a plus 1. No, you cannot change a. A is like a constant pointer. It's kind of like read only, right? So you cannot assign a value to this base address of the array. You cannot say a equal to a plus 1, or you can say a plus plus. No. You cannot say a equal to a plus 1. No. Or a minus minus. No. You cannot play around with a. It's like it's giving you the access to the base address. Read only. You can assign it to pointer and then you can do all these operations on pointer, but not on a. Now we have a solution to our earlier problem. And what is that? You remember we were passing the entire array to this display function by value and it was creating the copy, and we thought it's not a good solution. So now I'll call display again, right? Again, I'll pass the a and the size, but here now instead of using pass by value, I'll use pass by address, and instead I'll say star b, right? I'll use a pointer. So this base address a, right, will now be assigned to this pointer b. So because a gives us the base address, that is 1000, b will get the value 1000. So b will show the address 1000. And now I just told you that if we keep on iterating through b, right, n will be size 5. So you can use this notation b of I, which is also permitted, or you could use instead of that star at b plus I. Right? So you can print the values using b plus I, because pointer will increment by one step at a time. So it will try to point to next possible integer, and we will be able to print all integers. Let's say int star p equal to a, right? A is the base address of the array, that is 1000, right? Then you can access the first value as star of p plus 0, right? Or you can equally use the notation p of 0. These are the same notations. You can use either of them. P doesn't have to be array for you to be able to use this subscript operator. If it's a pointer, then also you can use like this. Then you can say star of p plus 1, p plus 1, it will store the address of next integer 1004. Star value at 1004, 22. Right? You can also use it like p of 1. This will print 11, this will print 22. Right? So both these notations are allowed, even if p is not your array. So that's why I can use it like this, star of b plus I, or I can say simply b of I. Even this is allowed in C language. Although b is not an array, it's an integer pointer. Let's talk a bit about pointer arithmetics now. Int star p equal to a. So I'm assigning the base address of the array to p, which is a pointer. So p is now storing the address 1000, right? And it also has some address of its own, correct? Then I say int q equal to a plus 1. A is 1000. A plus 1 is 1004. It's not 1001. It's a kind of pointer. So it will try to get address of next possible integer. Or I could also say, I'll say p plus 1, right? Now, p plus 1 is, it will increment by 4. It will try to point to next possible address. So p plus 1 is 1004. So q will store the address 1004. It will have its own address, let's say 3200. It's a variable, right? So first is you can increment pointer. We have already seen that. So you can say p plus plus, or let's say p equal to p plus 1, where p is a pointer. So in case it's an integer pointer, like in this case, when you say p plus plus or p equal to p plus 1, they will increment by, depends on their type. So if p is of type integer and p's value, that is p storing address 1000, p plus 1 will be 1004 because integer takes 4 bytes. If it's a character pointer, then character occupies 1 byte. So p plus 1 means the initial address stored by p is 1000, p plus 1 will be 1001 because character occupies 1 byte. Like that, right? It depends on the type of the element the pointer is pointing to, right? Now, so obviously incrementation is allowed, right? Similarly, decrementation is also allowed. P equal to p minus 1. So again, if p is currently here, right? P is a pointer to an integer and p is storing this address 1004. If you say p equal to p minus 1, it will try to point to previous possible integer. So it will reduce the address by 4. If p was 1004, then p equal to p minus 1 will make the address stored by p as 1000. It will reduce by 4 because it is trying to, it will point to previous possible integer here, right? So the point is, in pointer arithmetics, you can increment pointers, you can decrement pointers. Operations are allowed. One more fantastic operation allowed is that now that we know p is storing address 1000 and q is storing address p plus 1, that is 1004. What will happen if I try to say q minus p? What do you think will be the result? So basically, they won't just subtract the address values like 1004 minus 1000, so this is 4. No, you won't get 4, right? Instead, both of them are of type int star, like both of them are pointer to integers. So how many integers are they apart, right? So p here is storing this address, q is storing this address. So how many integers are they apart from each other? They are one integer apart from each other, right? So q minus p will print 1, right? If let's say p is here and q is here, right? Q is storing the address 1012, p is storing the address 1000. Both are pointer to integer. So when you say q minus p, how many integers are they apart? 1, 2, 3. So in this case, q minus p will give you answer as 3. So it's not like they just subtract the addresses, the address values from each other. They subtract by how many integers are they apart from each other, right? So that is 3. Surprisingly enough, if you do ulta, if you say p minus q, right? The address stored by p is 1000 and address stored by q is 1012, right? These are the addresses stored by P and Q. They are pointers. If you say P minus Q, right, you'll actually get the result as -3. So they are 3 integers apart in distance, but in opposite direction. So again, it's quite a fascinating one. So what kind of arithmetic operations are possible on pointers? Incrementation, possible. Decrementation, possible. Subtractions, possible. The arithmetic operation that you cannot perform on pointers is addition of 2 pointers. So you cannot say something like P plus Q. No, this is not allowed. What are you trying to do? You cannot add addresses. Like, we are not actually subtracting addresses, right? We were just calculating how many integers they were apart, those 2 pointers. We did not actually subtract the actual addresses. So similarly, you cannot add addresses, right? So that is not possible. Addition of 2 pointers, not possible. So on those same rules, multiplication and division are also not possible for 2 pointers, right? So only arithmetic operations possible are incrementation, decrementation, and subtraction. Cool. Now that we have learned all this, right, I want to take your attention to the limitations of using arrays and how do we overcome those limitations using dynamic memory allocation. So let's study that in the next video.